This is a pre-lab for Equilibrium and Le Chatelet Principle Lab. What you have to turn in besides the lab report, you have to don't do the second exploration, just do the one with the acid and dichromate. Okay, so just do the first one, don't have to do the second one. Other thing is, be very careful with this one. Dichromate is really toxic. So kind of scarily so. It's a carcinogen, and it causes acute and chronic effects. It's a carcinogen, and it gives you a rash. And also hydrochloric acid. It's a strong acid that can cause um, tissue protein damage, and even faster for your eyes. So make sure you're wearing gloves and glasses. And this is one you do not want to do around food, and keep the pets and kids away from this one. Okay, so this one, I'm actually kind of surprised. Me personally, I would have you guys use tea and vinegar to do Le Chatelier's principle, but it's not my choice. So this is what you need: coffee cups. This is for the hot and cold solutions, and there you go. And you need tape, just so that for the pipettes, when you put the solution in, they stick down there. And this is what Hands-On Lab supplies. So again, please be careful with this one. Oh, and when you submit a picture of the hot and cold solutions. So and we're not going to do this one, so do not look at the equilibrium of ferrocyanate. Look only at the chromate and dichromate. So here is how to open a pipette. This is, so you can see this here. I'm not going to play it. You can play it on your own. Yeah, potassium chromate. Yes, be very careful with it. So also make sure your 24 well plate is clean. So if you've been using it for other stuff, make sure it's really clean. So keep that in mind. And then snip off the potassium chromate chemical pipette. And if you get anything on the scissors, be sure to wash them. I mean, this is, like I said, I'm kind of scared of this stuff. I'm scared for you guys doing this. So I'll put 8 drops, as shown in Figure 5. And we're going to look at the equilibrium. So I guess I'll do a little bit of background. Remember Le Chatelier's principle. Well, here's potassium chromate, and it's going to be in equilibrium then. With hydrochloric acid, it's going to be in equilibrium with dichromate. So, you'll tell it by the color change. So if it's chromate or dichromate. And if you have any issues with color blindness or vision, let me know as well. We can sort that out. But we're going to be looking at Le Chatelier's principle. So the idea of Le Chatelier's principle is put a stress. So if you, here on the reactant side, if you add more reactants, it's going to shift away from that. So if you add reactants, you shift right towards the products. Or if you remove acid, you will shift left then towards the reactants. So we've already covered this in lecture at this point in time. So well, here's an ionic equation here as well. So, but you have this equilibrium, and also we're going to look at temperature as well. So look at the color. So anyways, do this and look at the color. Then add 4 drops hydrochloric acid, the potassium chromate, and towards the dichromate side, and look at the color change. Then add drops of sodium hydroxide until the color change is complete, which will bring it back towards the reactants. So look at how much sodium hydroxide you had to put in, and put that in table 1. Set up a cold water bath. It's easy. Just put ice cubes in a coffee cup or something. And a hot water bath. So use a tea kettle if you have it, or boil some water and have it hot. So and then you have the cold and hot water baths, and then put 8 drops of potassium chromate in an empty well, and then add 4 drops hydrochloric acid to that well. And then using a short stem pipette, pooled in, and so it's in the bottom. And look at this mixture concentration. It looks orange to me, just so you know, if you're wondering. And then so see if it's reactants or products flavored, and then put the reaction mixture into a cold water bath. And you have to tape it because it's going to want to float. So that's one thing here. It's going to want to float, so you need something to tape it down, scotch tape, duct tape, or something like that. And let it sit for a couple minutes. And then after you've been in the cold water for 2-3 minutes, take it out, and then if you want, you can swirl it. Again, be careful. It's probably be contained, but be very careful. Please be very, very careful with this. And then look at that data, and record it, and then put it in a hot water bath. Again, taping it so that it doesn't float, and let it sit in there for a couple of minutes. And then from this, look at the data, or record the data, and do that. And then put the caps on the hydrochloric acid and sodium hydroxide bottles. So you're going to need those as well. So keep this in mind. So this is the directions of shifting, and we're not doing with gases, but we're dealing with chemicals here. And so the equilibrium constant K for this equation, it's just going to be products over reactants, but don't forget that water is a liquid, is not included, so hint, hint. And then use this information to carry out the rest of these questions. So keep that in mind. So, but I think I'm going to leave you there for this this lab. And again, make sure it's nice and clean when you do this. So, well, happy exploring, and I'm going to sign off for now.